I'm going to talk about stage number 1, that it's about fluids. First, I'm going to explain you about a water distribution system. A water distribution system starts here, getting the water from a well with the help of a pipe. Then it goes here to a treatment place. In the treatment place, the water is cleaned so it won't harm us. Then, with the water cleaned, it goes right up here to a storage tank. As you can see, the storage tank is above normal buildings. This because of the pressure, so it won't affect the water getting to the houses. Then it goes down to an underground pipe, and that's how the water gets to the houses. Then I'm going to explain you about a gas distribution system. A gas distribution system starts here, getting the gas from an oil well or a gas well. Then it goes to a separation place to take out the oil in the water. Then, with only gas left, it is taken to a gas processing plant. In the gas processing plant, what they normally do is to take out non-hydrocarbon gases. Then, when they take out these gases and there is only natural gas left, it is taken to a compression station. Then, when the gas is compressed, it is taken to a mainline cell. Also, it is stored underground and it is sold to a gas company. So the gas company could send us gas, for example, to houses or companies. Then I'm going to talk about a drainage system, also known as river system, that are the patterns formed by rivers, lakes, or streams. The drainage system depends on the landscape, the place where it will be placed. There are a lot of ways to arrange a drainage system, but almost all are arranged from the top to the bottom. Here is an example. Here are normal streets, and the drainage system goes here, like from the top, down, 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 down. And that's how a drainage system is arranged. But also there are other ways. Thank you, that will be all.
Hi, my name is Cecilia and I'm going to talk about heat. That is the topic of the second stage of our physics book. Heat is the transfer of energy from a hot object to a colder object. In the physics book, they divide subtopics in temperature, thermal expansion, and a definition of heat that contain another subtopics like specific heat, the laws of thermodynamics, and the transfer of heat. First, I'm going to talk about thermal expansion. The thermal expansion occurs when an object expands and becomes larger due to a change in the object's temperature. So this depends on the temperature. The temperature is a measure of the ability of a substance, or more generally of any physical system, to transfer heat energy to another physical system. The higher temperature of an object is the greater tendency of that object to transfer heat. The lower temperature of an object is the greater tendency of that object to be on the receiving end of heat transfer. So another subtopic is the specific heat. The specific heat is the amount of heat per unit mass required to raise the temperature by 1 degree Celsius. Then we have the transfer of heat, that is normally from a higher temperature object to a lower temperature object. Heat transfer changes in internal energy of both systems involved according to the first law of thermodynamics. So we have the laws of thermodynamics. That the first is the caloric theory. The scientists have long pondered the nature of heat. The most accepted notion of heat was one associated it with a fluid known as calorie. Then we have the second one, that is the fall of caloric theory. That Thomson was amazed by the high temperatures reached by the cannons and by the showings that were shed from the cannons during the boring process. In one experiment, he immersed the cannon in a tank of water during the boring process and observed that heat generated by the boring process was capable of boiling the surrounding water within a few hours. Thomson demonstrated that this heat generation occurred in the absence of any chemical or physical change in the cannon's composition.
Hi, my name is Jose Luis. I'm going to talk about stage 3, that is electricity, and I'm going to explain some concepts, and I'm gonna give you some examples and formulas to solve it. And the topics that are related to the stage electricity are the electric charge, the Coulomb's law, the electric field, electric potential energy, electric current, electric resistance, electric circuit, and the Ohm's law. So I hope you enjoy it. Well, we begin with electric charge, that consists is in matter, is made up of atoms, and atoms are made of element particles called electrons, protons, and neutrons. Electrons and protons have a property called electric charge. Neutrons have a neutral charge. That means that they don't have charge due to the lack of electric charge. Electrons have a negative charge. Protons have a positive charge. The electron's electric charge is minus 1.602 times 10 to the minus 19, and protons plus 1.602 plus times 10 to the minus 19. If an object loses electrons, another object will gain those electrons. The Coulomb's law. Charles Coulomb studied the laws of attraction and repulsion of charged particles at rest. If one charge is double 2q1 and the other is triple 3q2, the F is increased time its initial value 6F. The constants always will be 9 times 10 to the 9. We can state Coulomb's law as the magnitude of electric force between 2 point charges indirectly proportional to the product and inversely proportional to the square of the distance. The electric field. An electric field exists in the space around the region of an electric charge that experiments an electric force. An electric field has a magnitude and direction. The formula is E, that means magnitude of an electric measured in newtons and coulombs, equals to the force that receives the test charge in newtons divided with the Q value, that means the value of the test charge in coulombs. The electric potential energy. The device with the capacity to maintain a potential difference of voltage between 2 points is called electromotive force. This electromotive force is measured in volts. The formula is I, that means electric current in amperes, equals to the Q, that means electric charge in coulombs, divided in time, that is measured in seconds. The electric current is defined as how fast the electric charge flows. There has two type of currents, that is the series and the parallel combinations. Here are the examples of how you can solve each one. And the Ohm's law, that is the intensity of the current of a circuit is directly proportional to the potential energy voltage, that means voltage, and inversely proportional to the resistance. The formula is the current that is equal to the voltage divided of the resistance.
And I'm going to talk to you about the sounds. The sounds are or can be defined as vibration, that is a wave passing through the matter, and the sound can go through the air and water, and sometimes can be through the solids. The waves are divided in longitudinal and transversal. There are differences because the longitudinal can be in direct line and the transversal can be up and down. We have the speed of sounds, that it's measured the distance traveled of a sound wave in a dry air at 20 degrees Celsius. That is equals a speed of sound that is 343 ms/s, that's meter over seconds. It's affected by the temperature and the pollution of the air. In that moment, you can be in an air of more temperature or less, and that is going to affect the sound directly. And if it's another temperature of pollution, those things will be more slow. We have to the topic of the sound intensity, that is the energy carried by words per unit. And the method of measurement is to locate two microphones closer and a signal analyzed to compute the cross power between them and the sound intensity. Well, finally, we have the optical devices that are to create or manipulate or measure the electromagnetic radiation by a simplified system. So we can conclude that the sound is going to be more different in all the